boys on bicycles 20 miles apart began racing toward each other. The instant they started, a fly on the handlebar of one of the bikes started flying toward the other bike's handlebar. As soon as it reached it, it turned around and went to the other bike, and so on until the bikes met. If each bike had a constant speed of 10 miles per hour, and the fly was traveling 15 miles per hour constantly, how far did the fly travel?
Okay, let's do some math. The first thing that most students do, of course, is they draw a picture, or if they don't, you ask them to. And so here we've got two people on bicycles heading towards each other. They start out 20 miles apart, and there's a fly flying in between. And so students who've been, say, in algebra or algebra 2 know that they can use a system of two equations. If we're talking math, system of two equations to solve this problem. And so let's see. If the fly is flying in this direction, to our left here, towards our friendly little, let's call her Sue over here, then the fly started also 20 miles away from Sue and is flying toward her at 15 miles per hour. And Sue is riding towards the fly at 10 miles per hour. Well, if we use the formula D equals RT, then for Sue, we're wondering maybe how far she traveled, but we need to know how far the fly traveled. Well, if they started 20 miles apart and they met somewhere in the middle, then one of them, let's say the fly, put the fly over here, the fly's information over here, the fly traveled some distance, and that in 15 miles per hour times some time. And the times are going to be equal to each other, actually, because they will have traveled for the same amount of time. Sue, on the other hand, will have traveled 20 miles minus the distance that the fly traveled in 10 miles per hour times that same amount of time. If we use the method of substitution, then we can solve for one of these variables if we combine the two equations. Okay, so we've already got one solved for D over here. We can go ahead and take that D and plug it in to this D. So 20 minus 15t equals 10t. If I add 15t to both sides, then I have 20 equals 25t. And t equals 20 over 25, or 4 over 5. Well, of course we have to wonder, what is t equals 4/5? Well, we've been talking about miles per hour, so t must be 4/5 of an hour, and 4/5 of an hour equals 48 minutes. But the original question, of course, was how far did the fly travel in this particular trip? And so in order to find out that, we have to plug in this 4/5 into one of our original equations. And so the distance the fly traveled equals 15 times 4/5. 15 divided by 5 is 3, and so this equals 12, and our unit is miles. That's right, we're not done. We've got to keep going till the end. We know how far the fly traveled, but that's only for one trip between the cyclists, and the fly keeps going back and forth. So in this case, if the fly traveled 12 miles, then Sue traveled 20 minus 12 miles, which means she traveled 8 miles. And if these cyclists are both traveling towards each other at 10 miles per hour, then if Sue traveled 8 miles, then this guy over here traveled 8 miles. That is a total of 16 miles, and so we have 4 miles between them remaining. And we need to go back through and do the same problem over again and add up the total distance that the fly travels back and forth until there is no distance because the cyclists have met each other. Great idea. Let's check out this whole thing in physics. We've got our cyclist up here starting at 10 miles out from the center position. Going to ride at 10 miles an hour. That means you're going to do 10 miles in 60 minutes. Alright, we've got the other cyclist 10 miles out in the other direction, also going to ride 10 miles in 60 minutes. And so their linear representation is that they're going to head towards each other and meet right here at 60 minutes, and we'll call that zero position. The fly, meanwhile, has started at one of the cyclists, is riding at a faster rate, or velocity. We found out meets the opposite cyclist at 48 minutes. And so this is this fly's representation, and you can see that the slope, which represents the fly's rate, or its velocity, is a little steeper. And then that fly is going to head back out, and from some calculations, we can either do calculations or we can look at the slope here and follow the same slope and realize that that fly is going to meet about here, and then go back and back. Okay, so we've got a visual representation now of this fly's pattern going back and forth, which is hard to see over here, but that's fine. And so if we look at starting at negative 10 miles, once realize we're talking about velocity here, but if we talk about negative 10 miles, then as this fly moves towards zero position, where did it meet the opposite cyclist? At positive 2 miles. So if we add that up, it traveled a total of 12 miles. And so then we can look at from here to this next meeting place. It traveled back down these 2 miles, and then another about a half a mile. And then we could look at that in between here if we could see it, and we could add up very quickly the number of miles the fly traveled on each of its